So we have understood what is immutable, mutable. Mutable is something which can change, immutable which cannot be changed. Lists are mutable, strings are immutable, tuples are immutable. Okay. So now let us understand what is the difference, what is the meaning of the tuple data type. Like I told you, yeah, this is how X here is a tuple, because here I'm putting it in simple brackets. And then it is possible to change a tuple to a list, and it is possible to change a list into a tuple. Okay, so we can use the tuple and the list functions, list and function. You can see it is possible to convert a list into a tuple and all that. So if you want to convert a list into a tuple, use the tuple function. If you want to convert a tuple into a list, use the list function. So this, we have seen it in the last class. We simply say tuple into bracket, pass a list as parameter. Now what you get back is a tuple, and if I say list of this tuple, then I get a list back, that is cat dot. So this is quite simple. We use the list and the tuple. Now, what is the meaning of references? This is, I'm zooming through this because, you know, I have already explained this in the last class. What is a reference? Now remember, when we have simple variables of type string or simple variables of type integers, they are of type value, and there are a few variables of type references. Okay. For example, have a look at this. I have a variable here called as spam. I have a variable here called as spam, and in which I put the value 42. Then what I do is I declare one more variable called as cheese, and I put the value of spam into cheese. So now the value of spam is 42. The value of cheese is also 42, because we are putting the value of spam into cheese. So we have two variables, spam and cheese, which are 42, 42. Now I change the value of spam by putting 100 into it. So 42 will get deleted and a new value will be written in spam, that is 100. 42 is lost from spam. Now if I display the value of spam, it is 100, because the new value of spam is 100, and when I display the value of cheese, it is 42. So what I'm trying to say is that when I have a variable here and I assign this, whatever changes I do to spam will not happen to cheese. Cheese is a different variable. It has got a different memory location in which it has stored the value. Spam in the memory has got a separate memory location. So if I change the value of spam, it will not affect it in any ways the value of cheese. This is for simple variables of type string and of type integers. Now take this example. Have a look at this. I have a variable called as spam. Now this time it is not a simple string variable or an integer variable. It is a list. Spam is a list. You can see it's a list. It contains 6 elements, 0, 1, 2, 3, 4, 5. They are all integers. You can see that the name of the list is spam. Then I copy this spam into list. So now cheese is a new variable in which I'm keeping spam, the old list, that is 0, 1, 2, 3, 4, 5. So now cheese and spam, if you think are two different lists, it is not so. What happens is, in the memory, only one list will be stored. Spam also will be pointing to the same memory location. Cheese also will be pointing to the same memory location. So that's why when you do cheese of 1 is equals to hello, when you try to change the value, the first element, cheese of 1 is this 1. Cheese of 1 is actually this 1. So when I change it, I remove this, I want to put the value hello there. So the list gets changed. The list becomes now 0, hello, 2, 3, 4, 5, because I've changed the element of the list which is present at index 1 using cheese variable. So cheese of 1 is hello. If you think that spam is a different list, cheese is a different list, it is not right. Cheese and spam are pointing to the same list. So when I do cheese of 1 is equals to hello, and if I want to display the value of spam, I display the value of sum. And if you think that it should display 0, 1, 2, 3, 4, 5, but no, it will display 0, hello, 2, 3, 4, 5. Because you have changed the first element of the list using the cheese variable. And then after that, if I display the value of cheese, it will also be pointing to the same list. So you will get the same output, 0, hello, 2, 3, 4, 5. So what did you learn from this? What did we learn from this is, when I have a list pointed by some reference, if I create a new list, putting that reference into that cheese, remember that only the address is copied into cheese, not the entire list, which means that cheese will not create into memory a new list. So cheese and spam both will be pointing to the same list. If you do any changes to the list using one variable, it will be affected to the other variable. I changed the list using cheese variable. When I displayed spam, you can see that it is seen the display. Hello has been changed. The number one which was there is changed to hello, and that has happened to the spam because both spam and cheese are pointing to the same list. I hope this is clear. This is the concept of references. When you have a copy of the list, only the address of that list will get copied. So when I do cheese is equals to spam, in cheese the entire list will not be copied, only the address of that list will be copied. Okay, there is a little explanation of that. So now you can see this is a little explanation for that. I have a box here, in the sense this is a memory in which I'm keeping the list. And when I create two variables, remember there are two variables. And in the two variables only the addresses are copied. So in the first variable, what is the address? 57207444. In the second variable, the address is 5720444, which means that they're pointing to the same memory location. Now, yeah, spam, this is a little clear. We have spam here, we have cheese here. In the memory, we have a list 0, 1, 2, 3, 4, 5. Both of them are pointing to the same memory location. If I do changes to the list using cheese variable, spam also sees the same thing because the same memory location is getting updated. So this is a little diagrammatical representation of that. You can see that one got changed to hello. Now, in Python, it is possible to see the memory address of a particular variable. Okay, it is possible to see the memory address of a particular variable. If I declare a variable, if I want to know what memory location it is present at, I can use the id function. I can use the id method to see that. So if I have a variable called as howdy or x, y, whatever variable it is, if I say id of that, it will display me some number representation of the memory location, some number representation of the memory location. So id is basically used for that. So in the examination, they may ask you, why do we use the id function? So you have to say that the id function is used to know the numerical representation of the memory address. Okay, of the memory address. So now, here is a little example of that id. I have eggs here. What I have here is eggs, which is a list containing two elements, cat and dog. What is ID of eggs? I want to know what is the memory location of this eggs. So it says 35152584. Okay, so this is the address, you can say, of eggs list. Then what I do here is I append a new element to the list. So now I put moose. So now the list eggs has become cat, dog, and moose. So three elements are there now, because append, what does append function does? It, I will add this element to the list. Now after adding one element to the list, I check after that what is the address of eggs. So it shows me 35152584. Same thing it is. It is the same thing. And now what I do is I have eggs, and then I put a new list into it. Bat, rat, and cow. I put it into that list. Remember, this eggs is lost now. A new eggs is created. And if I now check what is the address of that eggs, it is different, because first I had declared this by putting a list into it. It was a different list. Now when I initialized it with a new list, the address of that list has changed. Okay, address of that has changed. Maybe we can just take an example and do this. File new. I will declare a variable x is equals to 100 and y is equals to 200. If I say print id of x, let us take only one example. Okay, let us take only one variable. Let us see what it does. So I have kept all my programs here. My Python test files is, so I'll say id example.py. id example.py is the name of my file. I go to the command prompt, I go to the D drive, cd Python test files, and then I want to run the program. So Python id example, and then it displays me some number here. Okay, 1746. So every time I run the program, it shows me that number. What is that number? It is a numerical representation of the address, memory address, where the variable x is storing its value. Now when I have y and I initialize it to 200, and then if I say print id of y, I say, so now if I save the program, I come here, you can see, you can actually see that there are two different numbers, 175.29.1929, this is 22. So for x it's a different location, for y it's a different location. So you know that every variable you declare in the memory, it has got a different address. Now let us do one thing, what I was telling you. I have a list called as spam, in which I keep 0, 1, 2, 3, 4, and 5. And then I have a variable called as cheese, in which I'm going to keep spam. And then I say print id of spam. I say print id of spam, and then print id of cheese. I say print id of cheese. File, save. I come here, clear the screen, run the program once again. And now this time you can see that both for spam and cheese, it is displaying the same memory location. Why? Because both of them are pointing to the same memory location. So if I do any changes to uh, the list using cheese of 0, let it be equals to hello. And if I say print spam, if I do, so I've done changes to the list by using the cheese variable, but when I display spam, even spam is getting changed, which means that both of them are pointing to the same memory location. So you can see the output, both of them are the same. Okay, and so on. Okay, first time when I executed that in the memory, it was a different memory location, but both of them were pointing to the same memory location. When I executed the program for the second time, you saw that the memory has changed, but both of them here, cheese and spam, are pointing to the same memory location. Okay, let us go back now. This is about that. Now passing references. Passing references is the same thing. Now, for example, let us say I have a function here. How do we define functions in Python? We use the def keyword followed by the name of the function, and then you have some parameter here. And then what I do is, whatever parameter I pass, whatever list I pass, I want to append it to it a word hello. What does the append function do? It adds one element, uh, hello, and then it will add it, it will attach it to the string. It will attach it to the list. So that list dot append whatever I'm passing hello. Now this is the function from here to here. It is over. Now what I do is I declare a list here called as spam. In that I have 1, 2, 3. I have 3 elements, 1, 2, 3, and then I call the function eggs. And then I pass this spam list as parameter. So spam is passed. What happens? Spam dot append will happen, hello will happen, and then I'll print spam. So it will display hello. So if I pass a list as parameter to a function, remember it is copied by reference. It is copied by reference, which means that the address is passed. The address is passed, and to that address, if I append anything, it will change the original. It will change the original list from the main program. I hope you understand. I hope you remember your pass by reference and pass by value. When you pass by reference, if you do any changes to the function variable, the changes takes place to the main variable in the main program. So if I do egg spam, call the function by passing this list. If you do any changes to this list here, will affect the main list. So I append hello, and after that I print spam. What is the output? You get 1, 2, 3, and hello gets attached to it. This is called as pass by reference. Then understand the copy and the deep copy functions. Why do we use the copy and the deep copy functions? In Python, it is possible. Now you understood what happened here. Look at this example. When I have a list here called as spam. I create one more list in which I'm going to keep spam. Now you know spam and cheese in the memory has only one list, but both of them are pointing to it separately. But there is only one list. But you want to create a new list itself. You don't want spam and cheese to point to the same list. You want a copy of cheese to be separate, a copy of spam to be separate. In that case, you make use of the copy function. Okay, there is a library called as copy, and you can see here you have to first import copy. Then I declare a list here called as spam, which contains a b c d 4 elements. And then id of spam is yeah, it displays that. And then if you want to create a new list called as cheese, you have to do copy.copy spam. If you want to create a new list itself, you don't want spam and cheese to point to the same list, only one list. No, you want separate copy of spam list, you want to have a separate copy of cheese list. So you have to do copy.copy spam, so a new list will be created into cheese. Okay, and then after that, if you display the id of cheese, it will be different. So this is different and this is different. I hope you understood why do we use the copy.copy function. The copy.copy function creates a new list altogether for the new variable. Two new memory locations will be reserved for the two different lists. A separate copy of list will be created for the new variable. This is what is done by copy function. Then there is one more function called as the deep copy function. If let us say your list contains, I have already told you that the elements of the list can be strings, it can be integers, it can be floating point numbers, it can be boolean values, okay, and it can also be another list. Okay, it can be another list. I can have this last element of the list can be another list. It can be one more square brackets there, and I can have another list there, which means that the element of the list can be another list. If you want to copy the entire list, including the list inside it, then you have to use the deep copy function. If your list does not contain an element which is another list, then you have to use copy.copy. But if you want to, if the element of the list is another list, then you have to use copy.deep copy function to create a separate copy for the new variable. Okay, so this is about copying, creating two separate lists altogether, copy.copy and copy.deep copy. When do we use deep copy? We use deep copy when the element of the list is another list. Okay, so that is an explanation. Now there is a little program here, but this is not there for the syllabus, so I'm not going to go through that. Then this is the end of the lists and tuples. Let us go to the next. These are some questions here. Obvious questions from the chapter. The fifth chapter is dictionaries and structuring data. I think let's go back to the syllabus. So what all we have studied? We have studied the lists. We have studied the strings. We have studied tuples. We have studied what is references. And the next is dictionaries and structuring data. Okay, I need a separate class for this. I will start it in a new class because this concept of dictionaries and structuring data is a little new. Okay, it has got no relations with the previous thing. So we need a new, a fresh class for this. Meanwhile, I think we can execute some programs and C of Python. Let us at least execute some programs and see. So what I did here is, let us take an example of the copy.copy function. So you know what happened here. What happened here in the first example is I declared a list which contains 0, 1, 2, 3, 4, 5. I copied spam into cheese, so both of them are pointing to the same memory location. The IDs are also same. When I do changes to cheese, display spam, spam also got changed. But now what I'm going to do is I'm going to do this. I'm going to first of all import copy. I'm going to import copy, and then I'm going to do copy.copy spam. Now cheese and spam have two separate lists altogether. If you display the ID of spam and cheese, it should be separate. It should be different. It should be different. And when I make changes to cheese, hello, it should not affect spam. Okay, so what I'm going to do is I'm going to print cheese and I'm going to print spam both. I'm doing change to which list? Cheese list. I'm putting the first element as hello. I'm printing cheese and I'm printing spam. So I saved the program. I came here. So here what all has happened. First it is displaying me the IDs of spam. You can see now the addresses of spam and cheese are different. First it displayed me print cheese. So cheese is changed. Cheese is changed to hello. but spam remains the same, 0, 1, 2, 3, 4, 5. So by now, by this you must have understood what is the meaning of copy.copy. Copy.copy will create a separate list altogether, which is having its own memory location for the this. All the elements of spam will be copied into cheese, but a separate memory location will be there. Both of them are pointing to the different memory locations. So I hope you understood what is that. Well, I think we can do a little introduction to what is dictionary data type actually. Um, Dictionary, it's like an array only. The only difference between a dictionary and a tuple is that a dictionary and a list is that elements of a dictionary can be accessed with a key, not an index. You know what is a list. You know that it is a sequence or it is a collection of elements, and you access elements of a list using an index. Index is always integer. Okay, cheese if is your list, cheese of 0 is the first element of the list, cheese of 1 is the second element of the list. So this 0, 1, 2, 3, 4 are the indexes, which are integers always. But a dictionary is also collection of elements, but to access the values or the elements of the dictionary, you make use of something called as keys. You make something called as keys. So a dictionary is always created with flower brackets. Each element of the dictionary, each element of the dictionary is a key value pair. It's a key value pair, key and then value, key and then value. If you want to access this value, let us say gray, you have to use the key color. If you want to access the value fat, then you have to access it using the key size and so on. Uh, so if I have a dictionary called as my cat, and if I say my cat of size, then it should display me the value fat. So you can see my cat of size is fat. If I say my cat of color, my cat is the name of the dictionary, my cat dot color, it should give me gray. It should display me gray, which you can see it here. So basically, you understood that a dictionary is also similar to lists and tuples, but the elements of the dictionary can be accessed using keys, not integer indexes. And then, yeah, from this it is clear that keys need not always be strings. Okay, you saw here that it is a string, you saw here that it is a string, you saw here that it is a string. It need not be always strings, it can also be integers like this 1, 2, 3, 4, 42, like that it can be. So, keys of a dictionary can also be integers. Then there is a little comparison between dictionaries and lists here. So I'm going to start this. I'm going to take some examples in the next class today. I will not start. Tomorrow we will start in the next class, that is tomorrow only. Okay, we will have this class on dictionaries. In fact, I had taken this class on dictionaries in the last year when this subject Python was there. When this subject Python was there for the sixth semester, I had taken these classes on dictionaries. I will just search if I have the videos on that, so that you can just go through the video and understand. It is the same thing. Okay, I've explained exactly what is the meaning of a dictionary, so you can understand it from there. Okay.